All right, let's get right into it. Today we're tackling a question that feels like it's been pulled straight from a movie. Is any of this real? The whole idea that we might be living inside some kind of gigantic computer simulation, well, it's not just for sci-fi anymore. It's a serious idea, one that philosophers and physicists are actually debating. So let's dive in and see what the argument is all about.
Okay, so to get our heads around this, we have to treat it as more than just a cool thought experiment. It's a real intellectual puzzle, and it messes with basically everything we think we know about our own lives. So let me just ask you straight up, how do you know, really know, that your world, everything you can see and feel right now, is actually real? It sounds like a simple question, right? But trust me, it opens up a whole universe of weirdness.
We've all seen this in movies, right? The Matrix, The Truman Show. The idea that our reality is just some big, elaborate illusion is a total staple of science fiction. But this is where it gets interesting. The simulation hypothesis has actually jumped off the movie screen and into the halls of academia. The big turning point really came back in 2003. A philosopher at Oxford, Nick Bostrom, published this paper that took the idea from just a fun what-if and gave it a seriously logical backbone. He basically forced the academic world to sit up and take it seriously. And that brings us to the very heart of the philosophical argument, what's known as Bostrom's simulation argument. And it's not a simple yes or no question. It's what's called a trilemma, where one of three, frankly, very strange possibilities has to be true. Now, before we get to the trilemma, you have to accept one key idea that the whole thing is built on. It's called substrate independence. It's basically the idea that consciousness, your mind, isn't magically stuck to your biological brain. Think about it like software. The same program can run on a Mac or a PC. Well, this theory says consciousness could, in theory, run on any computer powerful enough to handle it, not just the gray matter inside our skulls.
Okay, so here are the three options in Bostrom's trilemma. First, humanity just goes extinct before we ever get technologically advanced enough to run these kinds of super detailed ancestor simulations. Game over. Second, we do get that advanced. Maybe we become some godlike post-human civilization, but for whatever reason, we're just not interested in running simulations of our ancestors. Maybe it's unethical, maybe it's boring, who knows? And then there's the third option. We are almost certainly living inside a computer simulation right now. Bostrom's big point is, logically, one of those three has to be the case.
And this quote from Bostrom himself really gets to the punchline. If you think there's a good chance that a civilization like ours will one day be able to create these simulations, well, then you almost have to believe you're probably in one. Just think about it for a second. If they end up running millions or even billions of these simulated worlds, there would be way, way more simulated people than original biological people. The odds would be overwhelming that you are one of the simulations. So the philosophy is pretty compelling, right? It kind of makes your head spin. But what happens when we check the math against the actual laws of physics? Well, that brings us to our first major counter-argument, the absolutely impossible energy bill. See, this whole counter-argument boils down to a fundamental rule of our universe, something a physicist named Rolf Landauer figured out: information is physical. That means every single bit of data, from the state of a tiny particle to the thoughts you're having right now, takes real, actual energy to store and to process. It's not just some abstract concept.
So just how much energy are we talking about? Well, an astrophysicist named Franco Vazza actually did the calculations. To simulate our entire universe down to the quantum level, it would take more energy than actually exists in the universe. It's literally physically impossible. Okay, so what about just simulating Earth? Well, even that would require a truly insane amount of energy. We're talking about converting an entire cluster of stars into a power source or harnessing the energy it would take to literally rip our galaxy apart.
And here are the actual numbers from Vaz's research. Just look at that top line. To simulate the whole universe, you'd need a number of bits that's a 3 with 124 zeros after it. The energy needed is a number with 108 zeros. These numbers are so ridiculously huge, they're basically infinite for all practical purposes. Even a blurry low-res version of Earth needs energy on a truly cosmic scale.
And it's not just about having enough energy, it's about the rate you can use it. It's about power. Vaz's work shows that even if you could somehow get all the energy you need for a low-res Earth, and you ran it on the most efficient computer physically possible, which is basically a black hole, it would still take millions of years of computer time just to simulate a single second of our reality. The simulation would be running so slowly, it'd be completely useless.
So yeah, the energy budget seems to be a total deal breaker. But you know what? There's another problem. And this one is maybe even more fundamental. It's not about resources, it's about the very rules of our universe.
A study from 2017 by two physicists, Zohar Ringel and Dmitry Kovarzin, came at this from a totally different angle. They asked a simple question. Forget energy. Could a classical computer, even an infinitely powerful one, even run the software of our quantum reality? And their answer was a big fat no.
So here's what they found. When you try to simulate quantum stuff, the difficulty doesn't just add up, it multiplies exponentially with every new particle you add. This creates a computational nightmare called the sign problem. To put it simply, trying to calculate all the quantum interactions creates this massive storm of positive and negative numbers that basically cancel each other out, making it impossible to get a stable answer. It means the very operating system of our universe seems to be unrunnable on any classical computer.
Okay, so the case against us being in a simulation seems pretty solid. The energy cost is impossible, and our quantum physics just won't compute. Case closed, right? But what if the simulation isn't running in a universe that plays by our rules?
And this is where we get the final, absolutely mind-bending twist in this whole story. All of these counterarguments, they all assume that whoever is running our simulation lives in a universe with the same laws of physics we do. But what if their reality is fundamentally different from ours?
See, Franco Vazza, the astrophysicist who calculated the energy costs, he didn't stop there. He then asked, well, what kind of universe could simulate ours? And these weird-looking graphs show his attempt to find an answer. Each axis represents a different fundamental constant of physics, like the speed of light or the strength of gravity. And those bright-colored spots, those are the sweet spots, the combinations of physical laws in some other hypothetical universe that would make simulating our reality possible.
And what he discovered is that these bizarre combinations, they actually exist in the math. His simulations show that a universe with, say, a much, much faster speed of light, or a totally different gravitational constant, could have the insane computational power needed to run our entire universe as a program, and in real time.
So here's the bottom line, and it's a big one. The physics of our universe make it impossible for us to be a simulation running inside another universe that's just like our own. But it leaves the door wide open for us to be a simulation running in a totally alien reality, one that operates under a completely different set of physical laws.
And that just leaves us with this final dizzying question. If the rules that govern our entire existence are just software running on some cosmic hardware from another dimension that has its own alien set of rules, what in the world does that even make reality? It's a puzzle that, for now, is very much unsolved.